Okay, this is going to be a quick video talking about interconverting units of solution concentration. We're going to be given a solution that starts off in mass percent, and we're going to also have the density of that solution, and using that information we're going to convert those units into mole fraction, into molality, and then into molarity. Okay, so please excuse my subscripts. When I converted my file into explain everything, it undid my subscripting, so just make note of the formula of urea that those two should be subscripted. We're given, right, we have urea, we have its molecular weight. When it's saturated, it's 3.8 grams per 100 grams of solution, and it has a density of 1.15 grams per cubic centimeter. And again, my superscript got obliterated when in the file conversion as well. Okay, so our first question is simple, right? How many grams of water are in 100 grams of the saturated urea solution? Well, given our definition of mass percent, right, we have 53.8 grams of urea per 100 grams of solution. That is the definition of mass percent. So therefore we have a 53.8% solution of urea, right? So we're given a mass percent. But now to answer the question, right? If we have 100 grams of solution, right? Our grams of solution, if we only have two components, are equal to our grams of solute, which is the urea, plus the grams of solvent, which in this case is water, right? So our 100, right, in our percent, we've got 100 grams of solution as a given. So our 100 grams, we know that 53.8 grams of that is the urea, right? So we have an unknown number of grams of water. So our 100 grams of urea, which since it's in the definition is a perfect number, or 100 grams of solution minus 53.8 grams of urea would give us 46.2 grams of water. That is a number that we will need for later parts of the calculation. Okay, so we've got this same solution. We're going to work with the same solution all the way through. So what is the mole fraction of urea in the saturated solution of urea? Okay, well, we have to remember that mole fraction of urea is equal to the number of moles of urea divided by the total number of moles of components of the solution. So that's going to be equal to moles of urea divided by the moles of urea plus the number of moles of water. Okay, so we've got a lot of work to do. So we got to figure out how many moles of urea we have. So we have 53.8 grams of urea. And we know that 1 mole of urea is 60.06 grams of urea. And so that is going to be equal to 0.895, and I'll go with 77 moles of urea. Keep some extra significant figures, not rounding too early, or keep some extra decimal places, not rounding too early. They're not significant, but we keep them until rounding at the end. And then we're going to have 46.2 grams of water, the number we found in the last question. If you add up the molar mass of water, you find that 1 mole of water is 18.02 grams of water. And so again, keeping a little extra, so that's 2.56382 moles of water, right? So our mole fraction of urea is equal to 0.89577 moles of urea, spell urea correctly, divided by that same number, 0.89577 moles of urea, plus the 2.56382 moles of water, which is going to be equal to 0.89577 moles of urea divided by 3.45959 total moles, which gives us 0.25892 is enough. That's more significant figures than we need, right? All of our numbers had 3 significant figures, right? So to 3 significant figures, our answer would be that the mole fraction of urea in this solution is 0.259. Okay? So, next. Oh, this is a misprint, right? I noticed as I'm doing this, we have little m, so this should not be molarity, it should be molality. What is the molality of urea in the solution? Okay, and if we remember, molality is equal to moles of solute per kilogram of solvent, right? Molality differs from other units in that we have a defined amount of solvent as our denominator of our definition. So what is the molality of urea in the solution? I apologize for the typo in this. So if we start this out, we have a solution that we found out, right? There were 53.8 grams of urea per 100 grams of solution, but that also meant that we had 46.2 grams of water, where water is our solvent, right? And we're given the molecular weight, so we know that 1 mole of urea is 60.06 grams of urea, right? That will give us moles of urea per gram of water. But we want per kilogram, so we have to convert. We know that 1,000 grams is 1 kilogram, right? And if you multiply that out, you get 19.389 moles of urea per 1 kilogram of water. Right? Now, if we look, all of our numbers except for our volume have 3 significant figures, and so we have to round that. So it would be 19.4 molal. Remember, lowercase m is molal urea in the solution. 19.4 molal. Okay? So now we've got it right. Capital M is molarity. So the question is, what is the molarity of our solution? Okay, so we go back to the definition of our solution, right? And our solution has 53.8 grams of urea in 100 grams of the solution. And again, we're given the molecular weight of urea, so we know that 1 mole of urea is 60.06 grams of urea. And here's where we need the density, because in molarity, it is moles of solute per liter of solution. Right? Right? Capital M, molarity, is moles of solute per liter of solution. So we're starting off with grams of solution, but our molarity will let us connect our mass to the volume. Right? So we know that 1.15 grams of solution is 1 cubic centimeter. That's given. And we know that 1 cubic centimeter is 1 milliliter. And we know that there are 1,000 milliliters in 1 liter. And when we multiply that out, you get 10.3014 moles of urea per liter of solution. And when we round that to our 3 significant figures, because of the way the numbers were given in the problem, we get that the best representation of our solution is that it is 10.3 molar in urea. So capital M is molar. I hope this was helpful. Good luck working your problems.